Okay. Myself, Dr. Saurabh Devnath. Today's topic is unsymmetrical fault. This is the first class on unsymmetrical fault. What do you mean by unsymmetrical fault? Let us go to the slide. Next slide. Here, what do you mean by unsymmetrical fault? Unsymmetrical fault gives rise to the unsymmetrical fault current. That means that unequal fault current in each phase and the phase displacement is not equal to 120 degree. This is known as unsymmetrical fault. Here it is written, those fault on the power system, this is the pen, those fault on the power system which gives rise unsymmetrical fault current, that is the unequal fault current and unequal phase displacement, are known as unsymmetrical fault. Now goes to the example of unsymmetrical fault. Let us the example. If there is a single line to ground fault is the example of unsymmetrical fault, or double line fault is the unsymmetrical fault, or double line is grounded, it is also classified as unsymmetrical fault. Now solution of the unsymmetrical fault. In the symmetrical fault, you know that there is the equal phase displacement between the three phases and the phase current is similar. But in case of unsymmetrical fault, the fault current is unequal and phase displacement is not 120 degree. That's why in case of unsymmetrical fault, there is a special method of solving the unsymmetrical fault. First method is Kirchhoff's law. Kirchhoff's law is the basic law by which any kind of electrical network can be analyzed. And the another is symmetrical component method. It is also known as Pocheskas theorem. This Pocheskas theorem is the basically powerful tool for making the unsymmetrical fault analysis. We are going to the Pocheskas theorem. In 1980, C.L. Pocheskas produced this theorem. In this theorem, a unsymmetrical fault is divided into three portions. One is positive sequence component of the current. Positive sequence component of the current is nothing but the current of equal magnitude and the phase is counted clockwise direction. Where and the second one is negative sequence component of the current. The negative sequence component of the current is you are denoted the phase in anti-clockwise direction and the phase displacement is here also 120 degree. And the zero sequence component of the current, in zero sequence component of the current, the phase displacement between two phases is 0 degree. Now let us go to the figure. This is the positive sequence component of the current. This is the red phase. Sorry. This is the R phase, B phase and Y phase. Here we are counting the phase sequence is R, Y, B in clockwise direction and each phase is 120 degree phase displacement. The negative sequence component is shown in the figure. Here R, Y, B is counted in anti-clockwise direction and the phase displacement is 120 degree. And this is the zero sequence component of the current. Here the phase displacement between the two phases are 0 degree. Now these are this positive sequence, this negative sequence and this zero sequence component of the current is both all are the balanced in nature. But when we are getting the effect of the unsymmetrical component, we are simply summating the three sequence of the current. That means that positive sequence component of the current, negative sequence component of the current and zero sequence component of the current. It is summative, and we are getting the total unsymmetrical fault current through the R phase. Okay. Similarly, we are getting the total asymmetrical fault current through Y phase is positive sequence component of the current, negative sequence component of the current, and zero phase sequence component of the current. Similarly, you have getting the sequence component of the current for B phase, positive sequence, negative sequence, and zero sequence. Here, the three sequence component of the current, that is the positive sequence IR1, IY1, and IB1, negative sequence component and zero sequence component of current are balanced, but the summative effect is unbalanced in nature. Symmetrical component theory applies equally three-phase current and voltages. Okay, and if there is the you are applying the sequence component of the current for symmetrical fault, then automatically the negative sequence component of the current and zero phase sequence component of the current will be nullified automatically. The symmetrical component method do not have separate existence. It is exist only for asymmetric unbalanced current or voltage with simply addition of the current and voltage for three separate systems. Thank you.